Hello, hi, Assalamualaikum. Today I will present on the introductions of our project, that is one wheel of an automobile. So the introduction part is the mass spring damper model consists of discrete mass nodes distributed throughout an object and interconnected via a network of springs and damper. This model is well suited for modeling objects with complex material properties such as non-linearity and viscoelasticity. To run the simulations of our project, we use the MATLAB, and this spring mass damper theory are applied the basic physics of force equal to ma, F equal to ma, to define suspension's motion and respond on bump impacts. So the force F acting on the suspension is the combinations of spring plus damping. Mass M is the chassis of wheel, weight depending on which body you want to look at. So the combinations of force and mass is defined as the F equal to ma acceleration, which in turn defines the velocity, position and suspension response characteristic at any instant time. Next, the spring and damper system in this intermediary between forces travelling from the road surface, the wheel and into the chassis and ultimately dictate the dynamic response of the car. Tuning of the spring and damper system has considerable influence on seat performance. Okay. The spring allows the seat to move up to absorb bumps in the person sitting on it and reduce jolting, while the damper prevent bouncing up and down. Various mechanical links keep the seat in line. Okay, that's it.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAZIRAH. I will present for question B. The control design of an automobile driver use a control system to maintain the speed of the car at desired speed. The speed and acceleration of the car is determined and controlled by the driver. Driver has to manipulate the acceleration, brake and steering wheel to control the car. Then the speed motor will display at towards speed. In addition, in an automobile driving system, the brain of the driver acts as an error detector. The system is a closed-loop control system. For question C, the block diagram, we use desired speed and actual speed. For the controller, we use driver, and processor, we use automobile and engine, and the sensor, we use speedometer. That's all. Thank you.
Assalamualaikum. My name is ROSLI. So today I will present about the model system. Alright, to get the model system, we use the mass, spring and damper. Value of mass is 215. Value of spring is 25,000. And also last value of damper is 1,500. And we get the equation for the model the system. Alright, to get the system transfer function, we rearrange from the model system. Alright, value of system transfer function is 2015 over s squared plus 100s plus 6. So this is the system transfer function for this assignment. So that's all. Next, how to calculate the steady state error for step input, right input and parabolic input. So first, before to calculate step input, right input and parabolic input, we need to know for pulse transfer function and position constant, velocity constant and acceleration constant. So value of position constant is 41.67. Value of velocity constant is 0. Acceleration constant is also 0. So from that, we can calculate the step input, right input, and parabolic input. So for the step input, right input, and parabolic input, we need to use the formula that given, and we get the value. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sofea binti Mak Fauzi. My number battery is B0821110431. Common use in MATLAB. We use num1 equal to 250. Then 1 equal to 1, 106. System 1, we divide TF, num1 and then 1. So we divide it by 250, divide S equal to time 100S plus 6. And continuous time transfer function to step system 1, and then the step response that we get is over them response. So we get TS, TR, and TP. Then the comparison of calculated value and measured value. For the calculated value, peak time TP we get 0.063 second, TR 18.24 second, settling time TS we get 0.08 second, and OS percent of overshoot is 8.61%. For measured value, TP we get 0.063 second, same like calculated value. TR we got 60 second, TS we got 64.4 second, and overshoot we got the same value as calculated value is 8.61%.
Next, how to convert the system transfer function to state space representation. Alright, to get from the system transfer function to state space representation, we need to know x equal to ax plus bu, y equal to cx plus du. So from that, we rearrange the equation. We rearrange that formula. Then we just put the value at the formula that given, and just follow the step. And lastly, we can get the y equal to 1, 0 for the metric. Alright, that's all. Next, the stable of the system. So how to know the transfer function is stable or not? We use the RH table method. So from what I learned, from RH table, there are no sign change, mean the system is stable. Thank you. Alright, next, how to calculate the peak time, setting time, and percent overshoot from the transfer function. Alright, from the transfer function, we need to equal the formula that given, which is omega n squared over s plus 2 zeta omega ns plus omega n squared. So how to get the peak time? We need to find the omega n and also damping ratio. To get the omega n, we need to get the omega n is from that equation, from that transfer function. To get the damping ratio, we need to use the formula 2 zeta omega n equal to 100. So that we got the value for the damping ratio. So the peak time, we need to use the formula that given. Then we get the exact value for the peak time. Also the rise time and setting time, we need to use that formula that given, and we can get the value exact. Alright, for the percent of overshoot, also we need use the formula that given. and lastly we get the value.
So the conclusion is, to conclude our project is, it is a second order system. The second order system is the lowest order system capable of an oscillatory response to a step input. As a result, the response are overdamped. Second order system that we use in an automobile that maintains the speed of the car at desired speed. For example, the situation is when a man driving a car on the road speed and accelerations of the car is determined and controlled by driver by observing traffic and road condition. Driver has to manipulate the accelerator, clutch, gear level, brake and steering wheels such to control the car. Then the speedometer provided to display actual speed on the panel. Next, the block diagram model system transfer function was obtained from the second order system. Explain how the system does work when the user starts the car. In an automobile driving system, the brain of the driver acts as an error detector. Is the error signal given to the input of the controller. These are the system in which the control action depends on the output. This system have a tendency to oscillate, for example, temperature controller, speed control of the motor, and system having sensors.